So welcome students, welcome to all of you in this video lecture. In today's lectures I am going to explain you the topic geometric progression. So students, first of all of you should know what type of progression is called a geometric progression. It is a type of geometric progression. It is a type of progression where there is a common ratio between the consecutive numbers. Like arithmetic progression, there is a common difference between two consecutive numbers. In this type of progression, there is a common ratio between two consecutive numbers, and this progression is called geometric progression. So geometric progression. Students, let us consider a geometric progression with first term a. Okay, like AP in geometric progression also first term is written by a. So let a be the first term of a GP. GP is short form of geometric progression, and R be the common ratio. Now A is the first term of that GP, R is the common ratio. Then a GP geometric progression can be written in the form, then GP can be written as A is the first term, AR is the second term, AR square is the third term, AR cube is the fourth term, and so on, and the nth term is AR to the power n minus 1. Student, you can see that here the first term is A, and if you divide second term by first term, it will get R. If you divide third term by second term, you will get R, and so on. Okay, so R is the common ratio between two consecutive numbers. So R is common ratio and A is the first term. And what is the nth term of this series? Nth term of this GP geometric progression is A R to the power n minus 1, and it is written as nth term is written as Tn is equal to A R to the power n minus 1. For example, 2, 4, 8, 16, 32, and so on is a GP series. Now why it is a GP series? Here A is the first term, A is 2, and R is nothing but T2 minus T1, T2 by T1. T2 is the 4 and T1 is 2, so it is 2. Similarly, it is same as T3 by T2, so it is 8 by 4, it is also 2. So you can see that R is common ratio of this progression. So this is an example of geometric progression. So student, this is the nth term of geometric progression. Like arithmetic progression, we can find the sum of n terms of GP series also, and the formula for sum of n term of GP, is Sn equals to A into 1 minus R to the power n divided by 1 minus R if R less than 1. Here if the value of r is less than 1, then we will use this formula, and if the value of r is greater than 1, then we will use this formula, r to the power n minus 1 divided by r minus 1 if r greater than 1. So these are the two formulas for sum of nth term of GP we will use for two different cases. For r less than 1, we will use a into 1 minus r to the power n by 1 minus r, and for r greater than 1, we will use a into r to the power n minus 1 divided by r minus 1. So these are two formulas. Now in other case, when there are infinite number of terms, means there are not n terms, suppose we are going to find the sum of infinite GP series. Okay, the sum of infinite GP series will be S infinity. It is directly you can find a by 1 minus r. So this is the formula for finding sum of infinite GP series, where the number of terms are undefined, not finite. It is infinite number of terms. So students, I hope all of you understood the basic idea of geometric progression. I'll just give a small short revision. R is common ratio, A is the first term, so a GP series can be written in the form AR square, AR cube. In this GP, A is the first term, R is the common ratio, and n term is AR to the power n minus 1. So n term of GP can be written as Tn equal to AR to the power n minus 1, which is the formula for finding the particular term of a GP series. Now number of terms is similar to in AP series, like how many terms are there? There are n number of terms are there. So number of terms will be the number of elements present in that particular progression. Sum of n term of GP series, there are two formula. One is Sn equal to a into 1 minus Rn by 1 minus r if r less than 1, and another is a into Rn minus 1 by r minus 1 when r is greater than 1. And in case if GP is an infinite GP series, then S infinity, the formula for sum equal to a by 1 minus r. The students, I hope all of you understood the basic idea of GP series. Now I am going to solve few questions based on this topic. First question is, question number, you can see that in your exercise 9.3, question number 1, it is given that, question is given, find the 20th and nth term of GP, right? Find the 20th and nth term of GP 5 by 2, 5 by 4, 5 by 8, ... So student, we have to find the 20th term of nth term of this GP. So very simple, in the given GP, given geometric progression is 5 by 2, 5 by 4, 5 by 8, ... Here first term a equal to 5 by 2, r common ratio is T2 by T1, so T2 is 5 by 4 divided by 5 by 2, so it is 5 by 4 into 2 by 5, so 5 cancel, it will be half, so r is half. Now we have to find the 20th term, right? What is 20th term? Now T20, the formula is formula is a r to the power 20 minus 1, right? We know that the formula of Tn is a r to the power n minus 1. So for T20 it will be a r to the power 20 minus 1. So what is a? A is 5 by 2 into r is half to the power 19, right? So we can write this answer as 5 divided by 2 to the power 1 into 2 to the power 19. It will be 2 to the power 20. So this is the answer of first question. And Tn, the n term is a r to the power n minus 1. A is 5 by 2 and Rn is half to the power n minus 1. So it is 5 by 2 into 1 by 2 to the power n minus 1. So 5 into 5, because 1 to the power n minus 1 is 1. So it is 2 to the power 1 plus n minus 1. It will be 2 to the power 1 plus n minus 1. So it is 1 cancelled. So it will be 5 by 2 to the power n. So this is the answer of the second question, the n term of this GP. So students, I hope all of you understood. Now let us take another question, which is question number 5 from a textbook. Question is, which term of the following sequences, which term of sequence root 3 comma 3 comma 3 root over 3 comma dot 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 is 729. So students, we have to find which term of this GP series is 729. So we have to find the n, right? The solution here, given series, given GP is root 3 comma 3 comma 3 root 3 dot dot dot. Here first term a is root over 3, common ratio 3 by root over 3. So it is root 3 whole square by root over 3. 1 root 3 cancel. So it is root over 3. Now we have to find n, we have to find out, and Tn, the last term is given 729, because we have to find the number of terms where the last term is 729. Which term is 729? So we have to calculate the n. We know what is the formula of Tn. I have already explained, a r to the power n minus 1. So Tn is 729. So a is root over 3, right? And a is root over 3, and r is also root over 3 to the power n minus 1, right? Now 729, as we know that 729, it is 981 into 9. So it is 3 to the power 4 into 3 square. That is, it is 3 to the power 5, right? So 729 is nothing but 3 to the power 5. So it is root over 3 into root over 3 to the power n minus 1. So we can write root over 3 1 plus n minus 1, right? So here 1 cancelled. So it is root over 3 to the power n. So we can write root over 3 to the power n is nothing but 3 to the power n by 2, right? So since base is equal, so you can write 5 equal to n by 2. So the value of n equal to 10. 5 to the 10. So students, I hope all of you understood this question. Here we have to equate this root 3 power. Here the root 3 power is 1 and here the power is n minus 1. So power is adding. So 1 get cancelled, it will be root 3 to the power n and 3 to the power n by 2. So base is equal, so power is also equal. So 5 equal to n by 2 we can write. So n equal to 10. So this is the answer of this question. The next question that I am going to discuss is question number 3. Question number 3. The question is the 5th, 8th and 11th term of GP are 5th, 8th and 11th term of a GP are PQ, and S. To prove that Q square equal to P into S. So students, question is very clear. 5th term, 8th term and 11th term of that particular GP are given P, Q, S. The solution, what is given? 5th term means what? T5 is given P, T8 is given Q and T11 is given S. Since here first term and the common ratio is not given, so let us take, let A be the first term, and R be the common ratio, right? Now using the formula T5, now T5 equal to P. So what is the formula of T5? AR to the power 4, 5 minus 1. So it is P. So put equation number 1. Also T8 equal to Q. So AR to the power 8 minus 1 equal to Q. So AR to the power 7 equal to Q. Put equation number 2. Right. And the last one, T11 equal to S. So it is AR to the power 11 minus 1 equal to S. So AR to the power 10 equal to S. Put equation number 3. Now see the question, what we have to find out. We have to find Q square equal to PS. So let us find out P and S. First of all, left hand side. Let us see what is left hand side, Q square. Now what is Q square? What is Q? From 1 we have AR to the power 7 whole square is equal to S square R to the power 14. So the value of Q square we have got S square R to the power 14. Put equation number 4. That is the value of left hand side, because Q is AR to the power 7. So its square is S square R to the power 14. Now we have to find P into S. P into S. So PS, now PS, P is AR to the power 4 into AR to the power 10. So in multiplying S square into R to the power 14, so PS equal to S square R to the power 14, equation number 5. So from 4 and 5 we get Q square equal to PS. Proved. Students, I hope all of you understood this question where we have solved both left hand side and right hand side, and we have verified the result that both left hand side and right hand sides are equal. Another question, question number 11 from a textbook. Question is, evaluate the summation of k equal to 1 to 11, 2 plus 3 to the power k, 2 plus 3 to the power k. So student, this question actually, I hope all of you know the meaning of summation. Summation means sum of the terms from first term to 11th term, right? So let us expand this one. The solution given sum is summation k equal to 1 to 11, 2 plus 3 to the power k. So let us expand this one, right? 2 plus, first term is 2 plus 3 to the power 1, right? Plus 2 plus 3 square plus dot dot dot. The last term is 2 plus 3 to the power 11, right? Now in first bracket we write all the two terms, 2 plus dot 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 2, and in second bracket 3 plus 3 square plus dot 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 3 to the power 11, right? Now here there are 11 2's are there, so you can multiply 2 into 11, and this is the sum of GP series. Here the first term A is 3 and common ratio 3 square by 3, which is 3. The formula is A and R is greater than 1, so second formula R to the power n, so 3 to the power 11 minus 1 divided by 3 minus 1. This is the formula for sum of 11 terms of GP. So it is 22 plus 3 into 3 to the power 11 minus 1 divided by 2. So you can keep your answer up to this. So this is the answer of this summation. So students, I hope all of you understood the questions what I have discussed today in this geometric progression. In the next class I will discuss more question, and if you have any queries you can ask me. So I am going to finish my today's lecture. Thank you very much.